Hey guys, welcome back to the channel, and today is our class 3 of Solidworks basics. Now in class 1 and 2 we talked about getting started in Solidworks and the sketch entities that we have in Solidworks. If you haven't watched those classes, make sure you watch it before continuing this class. Alright, so in today's class we'll talk about the feature tools, basically the feature panel. As you can see right over here, we have different kinds of tool inside feature panel, such as Extruded Bar Space, Revolved Bar Space, and so on and so forth. We'll be utilizing all those tools in this tutorial. And what do we learn in this one? So we will be learning about obviously the feature tools. We will see how we can use these feature tools to create 3D objects, and yeah, let's see how we can utilize all these tools. So the very first tool that we have inside the feature panel is Extruded Bar Space. Now in order to utilize it, we need a sketch. So let's go for a sketch on top plane, and let's say I go for center rectangle. Can start anywhere around here and draw a rectangle. Then we can exit the sketch and we can call on the Extruded Bar Space. In the Extruded Bar Space, we can pretty much take this arrow and slide up, and we can see how the value of the depth is changing according to the ruler over here. We can, let's say, go for 20 mm, we can increase it up to 30 mm, go for 40, and stuff like that. Now you can also enter values directly in the depth option, so we can, let's say, go for 30 mm, and it knows up to where it has to go, right? The other thing that we have inside the Extrude Bar Space is the direction. So right now it's in blind, so it goes directly in the blind direction for about 30 mm. Now we can't use vertex and surface because we don't have any surface. Also we can't use offset from surface. Same reason, we don't have any surface. Up to body we can't use because we don't have any other body over here, but we can go for mid plane, and the body goes in body extrudes, our sketch extrudes in both the direction now, and it's 15 mm in one direction and 15 mm in the other direction, so that makes overall 30 mm. Now if I keep it for blind, I can also give my object draft. So if I switch on the draft from here, and let's say go for a 25-degree, you can see the sides are slanted inwards towards to an angle of 25-degree. Now mind that this is an inward draft. All right, the body in the sides are going inside, but we can also make it reverse, or you can say draft outward by checking the draft outward box over here, and the body, you can say the sides moves outward at a draft angle of 25-degree, right? So that's it with the draft. I can undo that and keep it in the blind and press the green tick to confirm. Now I can also select this face and go for a sketching. So let's say we go for a sketching, normal to, and we take a rectangle. So we'll take a corner rectangle, and I will start from here and up to here and exit the sketch. I can pretty much utilize the Extrude Bar Space to give it a L shape like that. We have a L shape object over here. Now in order to understand the different direction inside the Extrude Bar Space, let's go for a sketch on right plane. Go to sketch, and this time I will be selecting the circle like that and exit the sketch. So as you can see, we have our circle on the right plane, and this time when we go for extrude, I can use the blind operation to go from, to make it to this big, or we can use through all, so it knows where it has to end. and obviously this the previous body ends over here, so it knows that it has to go up to that point. And we can also utilize up to surface. So let's say I can go up to only this surface, or I can change it to up to this surface. Alright. Also we can go for offset from surface. So if we select that and we select it, this one, let's say we go for this face, we can pretty much change it to 20, and it knows that. So in the direction for extrusion, I can select the axis like that, and we can change the offset distance. So you can see, can go for reverse offset. You can opt out of merge result, and yeah, that's it for offset. And we can also go for up to body, so I can select this body and our extrusion will go up to that body only, right? So yeah, that's it with the Extruded Bar Space command. Most of the 3D modeling will be done using the Extruded Bar Space, and it's the godfather of 3D modeling, I can say, inside SolidWorks. Alright, so to understand the extrude cut option inside SolidWorks, we have to quickly create a sketch. So let's say I can select this face, go for a sketch, go for normal, and I can pretty much take a corner rectangle and draw a rectangle like this, and we can exit the sketch now. Now we will start the extrude cut, and if we can see, we have the same option that we had in Extruded Bar Space. So we can go for blind, we can go for through all, we can have different options. So let's say we keep it in blind and press the green tick, so it cuts right away. The sketch is going, the cut is going right through uh, this area. All right, now let's go for another cut. So for that I'll sketch one on this face and go for normal. Let's say I go for a corner rectangle again. I'll quickly go for a small rectangle like that. Right now if I go for extrude cut, I can change it to through all, so it includes whatever it is saying in its way, and it goes entirely through the bodies that it encounters while cutting. Now we have through all both, so we can go in either of the direction, and we can go for up to next. So in up to next, it cannot uh, extend up to this one. That is because if we see, these are two bodies, so this is another body and this one is another body. Alright, so up to next will only take up to the single body, only one body at a time. Now we can also go for up to vertex, and let's say I can give it this point, and it cuts up to that point, right? We can also go for up to surface, so I can select this surface now, and it cuts up to that one. Pretty self-explanatory. And we can go for offset from surface, and let's say we offset it for about 5 mm. Offset from surface, let's select this surface, we can go for 5 mm. So it knows the distance from this surface, and it goes on the offset of 5 mm, and up to that it will cut. Up to body, so I can go for this body as well, so it will cut right away up to the body. Alright, okay, so moving on with the feature panel tools in SolidWorks, let's talk about the whole wizard. So as you can see, there is a whole wizard panel over here, and if I click it, there's a whole bunch of options that we get inside, and we can pretty much go for different hole types. So we have contour bore, countersunk, and we have blind hole as well. We can go for tapered, we can go for straight tap, we can go countersink slot, all the different types of hole that we get. And below that we have standard, so we can go for different standard. And hole wizard consists basically different um, number of different standards you can define. So let's say you can go for ANSI inches, or you can go for ANSI metric, or you can change it according to your preference. And below that you can see the type, so we can go for tap drill, double holes, drill size, helicoil, all those different options. And below that we have to define the hole size. So let's say we can go for uh, 2.5 dia. And we can define the end condition, so we can go for through all or something like that of blind. So let's keep it to through all. And what else we have, so we can go for tolerance and all if you're going to define your serious hole specification. And once you have set your mm, desired type of hole, what you can do is you can come to position, and you can select your face, and you can place it just like that. So let's say I'm selecting this face, and as soon as I click on this face, it creates a hole, right? You can keep on clicking, and when it will add multiple holes. And as soon as if I press escape, I won't be able to create another hole. So what I will do is I'll create unnecessary hole by just clicking and deleting right from here, right? Now let's say your holes are too small. What we can do is we can go and we can pretty much confirm it, and then we can come to edit feature. We can come to our tree and edit our hole wizard feature. Go to edit feature, and let's increase the size to, let's say, 10. And that's looks fine, but I want to delete some of the holes. So what I will do is I'll delete this one, delete this one, this one, this one, and this one. And after that I want to give it a specific dimension, so I will start with this smart dimension. And let's say I can give it dimension like this. Okay, let's go for 75. And from here let's go for 50. So if it's too much, you can always go for change your dimension. Once you're done, you can press to see your hole, right? That's one way to utilize the hole wizard. Now obviously there are a bunch of different options that we have inside. So you can play with hole type, you can play with the standards, we can play with the type of hole. So basically we have different hole specification and everything and anything that you're gonna need while defining your hole. So yeah, that's it for hole wizard. Let's talk about the fillet option. So we basically use fillet to create a corner, a round corner. So we want to avoid the sharp edges, we can use fillets to round them up. Alright, now to use it, I'll just start the fillet right over here. And the first one is a constant size fillet, and we can define below that we have to specify the items to fillet, and there are a few more fillet options inside this. So we can go for fillet parameters, and this we have two different options. Now let's say we want to create a fillet of radius 10. Let's give it this value and select this edge. You'll get a nice preview of your fillet, and you can press the green tick to confirm your fillet. Nice corner is created, right? Now there are more tools inside the fillet. So this was the constant fillet, and if we look at the other fillet option, that is variable size. And if we select it, and let's say we want to give this one a variable fillet, and we have to assign the radius. So let's say I want to give it 5 mm, and this one, let's go for 15 mm, right? So you can see a nice preview of the change in the radius while doing the fillet. You can also create new points. So let's say I can click over here. Yeah, let's go for 5. Let's go for 15. And I can come here and add one more point. And let's say I go for 10. You can see how the values are changing. I can give it 12 and so on and so forth. And once you are happy with it, you can see the variable radius parameter. You can change it from here as well. You can come and change the value of your radius, and you can pretty much change the profile. So you can play with circular and different options over here. You can press the green tick to confirm, and you can see a variable radius fillet in your part. Okay, so let's see the other fillet option, which is face fillet. Now, in order to use that, we have to define the face set 1 and face set 2. So let's say we select this one as face set 1 and this one as face set 2. Now you won't see any preview because of your radius. So if I decrease it, you can see a nice preview of your fillet, and if I press green tick, you'll see a nice corner over here. Obviously, this face fillet is dependent on your extrusion. So if the extrusion is not uh, big, then your radius needs to be small as well, because it's directly dependent on how your part is extruded, right? So keep that in mind, that make sure your radius is according to your extrusion, right? And then I start with my full round face fillet. So face it 1, face it 2, and face it 3, and there you go. You have a nice full round fillet between those three faces, right? Pretty impressive. So yeah, that's it with the face fillet. And in the normal fillet, if we go and edit the feature, you can see we have some other bunch of options such as asymmetric. So we can go for different values to each of the radius. So one direction we can go 60, and the other direction and we can go for different radius. We can reverse that as well. We can go for conic, we can go for curvature continuous, and different stuff like that. So in the edge fillet option, we have some other options, such as we can go for asymmetric values. So we can pretty much increase this one, and we can reverse that as well. We can give individual radius to both the direction. Also, we have option to create a conic row, profile, or curvature continuous. All right. Now we also have options such as setback parameters and partial edge. Now if we press it on, what we can do is if we zoom in, and we can uh, change these small dots like that, and as the name suggests, we can create a partial fillet between those 2 points, right? The rest of the edge is discarded, but between those 2 points the fillet is created, something like that. So there is a bunch of different tools inside the fillet options. You can pretty much utilize it for your design purpose. Alright, so just like the fillet creates a round corner, there is one more option in Solidworks, which is called chamfer. So chamfer basically creates a slanted surface instead of a corner, right? So to define a chamfer, what we can do is click on chamfer, and then we have a bunch of different chamfer types. So this one is angle distance, distance, this one is vertex, distance, offset face, and face. So let's start with the angle distance. Alright, in the angle distance, what we can do is, let's say we want to chamfer this edge, and we can define the distance. So let's say we can go for 15, and we can change the angle pretty much over here. We can also flip the direction, so it goes that way, and most of the time we are using 45 degrees, so let's keep it to 45. Right, you can go for different preview option over here. You can also go for no preview, but let's keep it on to full preview and press the green tick once you are done, and it creates a slanted face over here. Okay, so the other chamfer option that we have is distance. So if I select it, and let's say I want to chamfer this corner, and right now it's symmetric, so even if I change the distance, you won't see much difference because it's symmetric. Now if we change it to asymmetric, and then we can pretty much apply different distance in different direction. So that's how the distance chamfer is working. Now if you are done with that, you can press the green tick to confirm, and you can see how the distance chamfer works. Right, let's go for the next chamfer option. So this one is Vertex, and in this one you can just if you want to chamfer, you can just select any of the corner points. So let's say I select this one, and you can either go for equal distance from here. So we have equal distance of chamfer in all the direction, or you can pretty much change the values from here. So you can see how this different distance can be used to create a vertex chamfer. Let's go for equal distance, and let's change it to 10, and press the green tick to confirm. That's the vertex chamfer. The last one in chamfer, not the last one, but this is the offset face. So if you want to fillet, let's say this one, if we want to chamfer this edge, we can select the edge, and then we can go for symmetric or asymmetric. It's up to you. If you go for symmetric, you'll have only um, one distance to specify, and I think that's fine. Also, you can select multi-distance chamfer. You can go for partial edge, just like we did in the fillet option. So we can zoom in a bit, and we can change these endpoints, and once you are done, you can press green tick, and it will create only between those 2 points a chamfer will be created, just like we did with the fillet option. Now the last chamfer option is face. So for this one, let's say I select this face and this face, and we can provide chamfer between those two. We can either go for symmetric, or we can go for chord width, we can go for asymmetric, we can go for whole line, and different a bunch of different options. Let's go for symmetric, 10 mm, press the green tick, and you have the face chamfer. So that's it for the chamfer option in Solidworks. Okay, now so to witness the next feature tool, that is Revolved Bar Space, we obviously need a sketch. So let's quickly take a top plane and sketch, and we can start with a line. So yeah, let's start somewhere around here. Let's draw some profile. This needs not to be the same, but in case if we want to do the same thing, you can do. Right, so we need to merge those 2 points. So, right, after that what we can do is we can pretty much Go for smart dimension and give this dimension. You can do that, but I'm just avoiding that part, so I'll exit the sketch. And now let's start the revolved bar space. I'll select my okay. Before doing that, we can select our sketch and then start the revolved bar space. And you can see it asks me to select the axis of revolution. So what we can do is I can select this as my axis, and you get a pretty drum kind of shape over here. Right, you can go for different stuff as we have seen the direction in the extruded boss and extruded cut, the same options we have inside the revolve as well. So we can go up to vertex, up to surface, offset from surface and stuff like that. We don't have anything of surface, so we can't do it right now. You can change the pretty much angle, so let's go for 180, and you can see our drum is now half, right? Also you can come and delete this line, and this time you can change it to pretty much this one, and you can get a different shape. So changing the axis of revolution pretty much changes your entire 3D object. Alright, I can come delete this again, and we can select a new edge for rotation, so let's go for that one. And you can pretty much play with this one. You can have your own let's say axis, and then revolve it according to that axis. So that's how the revolve works in Solidworks. Let's keep it to 360 and press the green tick once you are done. Nice and easy, right? Okay, so the next tool in feature panel is Revolve cut. So it's just the opposite of revolve bar space. Instead of adding material, it can remove material in a revolve fashion. So if we want to do that, we need a sketch. So let's select this face, go for a sketch, and go normal to the face. Let's say I want to go for a center point arc from here, and I draw an arc like that, and take a line, and then join the endpoints of my arc. You can also assign dimension if you want to, but let's keep it simple. So I will exit the sketch now, and you have your sketch ready. So I'll select the sketch and go for revolve cut. Now it just like in the revolve bar space, it needs an axis for revolution. Same thing in the revolve cut, it wants an axis. So I'll select, let's say, this axis, and you can press the green tick, and you can see the material is scooped out from the part. Now you can always come and change the line of axis of rotation. So I can select this axis, I can change it to maybe 90 degrees, and you can see how it's working. Also you can, if you have different bodies, you can go for directions such as up to vertex, up to surface, and all those different options that we saw in the extruded boss. Alright, so let's keep it to 360 and change the axis to this one, and then press the green tick. There you go, you have the revolve cut. So by default, SolidWorks give you three fundamental planes, which are front, top, and right. Now let's say you don't want to use these planes and you want to create your own plane, maybe at a certain angle or certain direction. So SolidWorks has a tool called reference geometry, and inside that we have a plane definition option. Once you select it, you will be asked to select first reference, second reference, and third reference, like that. Now let's say I want to select my top plane. So if as soon as I select top plane, you can create plane at an offset distance of 10 mm. I can also increase that. So let's say 50. I can decrease that as well, and I can pretty much increase the number of planes. So let's say I want to create 2, 3, 4, and just like that I can create multiple planes from here. uh, right now, just in case I want to create a mid plane, I can do also that. Okay, so it's taking first reference as the top plane, and in the mid plane it's creating a mid of the top plane, it's creating a new plane, right? Let's go for flip offset. You can also do that. Let's undo that, and we can go for parallel again, and we can define the distance. So let's say we want only one plane, and distance could be, let's say, 30, and press the green tick once you are done. So we have our new plane on an offset of the top plane. Now let's say we go for a new plane definition, and this time instead of selecting the default plane as the offset, I'll select this face, and from here we can offset as well, right? And maybe we can come to a second reference and give it right plane reference, and you can see we can create a plane at a different angle, which was basically not available with the default plane. So using those two surface as first reference and the right plane as the second reference, I can create a new plane which is at an angle, right? We can play with this one. So let's say I want this as my first reference, and second reference maybe front plane, and third reference maybe this plane. Okay, third reference is not possible, so I will just delete that, and we'll happy with that. If you have any points or lines in your as our sketch, you can utilize those as well for your plane definition. You can see it creates a different kind of plane at such an angle. And if I select my new plane and go to sketch, go normal to, and let's say I take a circle, I can draw a circle like that and exit the sketch. And now what I can do is I can extrude cut it through all, and done. So you can see how the cut is going on, right? You can also do the extrude cut in both the direction through all, and press the green tick. Crazy type of hole is created, right, at a slant angle. So that's how you can use the reference geometry plane. Very useful tool inside SolidWorks. Okay, now so when we talk about Lofted Bar Space tool, which is right over here, it's used to basically create a shape between two different planes. So each of those planes have their own shape, and you can basically create a you can join those two shapes to create a 3D object. Now before using the Lofted Bar Space, we obviously need to sketch. So let's start with the top plane, go to sketch, and let's say go for a center rectangle, draw a rectangle like that, exit the sketch. You can give dimension if you want to, but let's say I'm happy with that. Now this is our top plane. I want to define a new plane, so let's go for reference geometry plane, and from the tree itself I will select top plane and move it a bit up. What is happening? Delete that. Let's say we want to go up to 80 and press the OK, and then we'll select the new plane, go to sketch, and we'll pretty much go for normal view and then select a circle From the center, let's say we draw a circle, exit the sketch. Now if we see, both these sketches are on different planes, and we want to make a loft using these two sketches. So let's go for loft, and obviously we need to give profile. So from the tree itself I will select my sketch 1, sketch 2, and as soon as I do that, you can see there is our loft right away created. And once we are happy, we can press the green tick, and there you go, you have the loft. Right, obviously there are, if we come to a loft and edit feature, there are much more options such as end constraint, start and end constraint, guide curves, all those different options which we will see later on. But if we come to start constraint, I can define my direction vector. Now these direction vector can be your construction line, can be your points on the sketch, but I don't have right now, so I'll go for normal to profile. And if I do that, you can see the start is going like a crazy. The start will be happening in a normal to the profile, and then you can stretch these arrows. You can also do this to the end constraint. So let's go for end constraint, normal to curve, and we can pretty much make it like that. So you can get a different type of loft using your start and end constraint. So press the green tick. You can see how your model is using the normal to profile stuff for the constraint. Pretty impressive feature in Solidworks. Now you can also use guide curves if you have. So let's say I'll keep it like this, undo that, I'll keep it like this, and what I will do is I'll create another plane. So let's go for reference geometry plane, select this plane as the reference, and yeah, fine. And I will select the new plane, go for a sketch, normal to, and this time let's go for polygon, right? So let's say I draw a polygon like that, exit the sketch, and what I will do is I'll delete the loft. And now we have 3 sketches. So I'll start with the loft bar space. From the tree I can select my sketch 1, sketch 2, and sketch 3. Now notice that we are not getting the preview of our loft. So what we can do is we can change these points basically. So you can play with these curve points, and then when you are happy you can press the green tick and you can get a lofted bar space created from 3 different sketches. Now you can have multiple sketches and you can combine them all together using the lofted bar space. Okay, so the another powerful tool inside SolidWorks feature panel is the shell command, which is right over here, and it's basically used to uh, remove the, you can say, used to hollow out the existing solid parts. So let's say you want to hollow out this box, you can utilize the shell command, and you can pretty much specify the thickness. So let's say go for 10 mm, and you want to specify the face. So let's say I went for this one. I can press the green tick and you can have the shell just like that. You can go to your shell and edit feature, and you can add faces such as this one as well, and now you can get a different kind of shell, uh, and each one has a 10 mm thickness. So each of this side has a 10 mm thickness, and we can add this face as well. So if I go to my shell, I can add this face, and we are just left with that face. So very powerful tool. You can pretty much use it to hollow out your 3D models and Okay, so in order to see the next feature panel tool, which is Swept Bar Space, we have I have already uh, created two sketch. One is this one, and the other one is just a simple hexagon. Now let's start with the Swept Bar Space. And in the profile and path, you want to select the profile. So from the tree itself, I'll select this one as my profile, and for the curve I'll select this one. And to do that, you can see a nice preview of your sweep, and you can press the green tick to confirm. This is an Allen bolt kind of shape. Now one thing that I want to mention in the sweep is you can you can have your own sketches for the sweep operation, but let's say you don't want it to be you don't want to select the sketch tool for the profile. You can always go for a circular profile from here, and you can, let's say, go for a 5 mm circle, and it will automatically add your or circle on the profile. So just like that, right? Let's say I'll use the sketch profile only, and then we have the option to add guide curves. We have the option for profile orientation and twist. Now profile twist is basically used for doing the cable or cord for, let's say, maybe a telephone cord and stuff like that. We will be using the profile twist operation, and for the start and end type we can use it over here. We can also use curvature display, which we'll see later in the further video. Okay, so there is another tool in feature panel inside Solidworks, which is, obviously, the draft. And what it does is basically tapers the faces. So basically it gives a slanted creates a slanted surface. So let's see how it works. So when I invoke the draft tool, I can select the angle for my draft. So let's say 15 degrees, and below that we can go for direction, and we can select the face. So let's say I select this one as my direction, and the face that I want to draft is this one. And if I go for OK, you can see there's a draft of 15 degree on that face. Now if I come to edit it, I can add this face as well, and we can see the change to both the faces, right? We can add more faces, so we can add this one and this one as well, and it will draft all the faces that we have selected. And there are a few more tools. You can go for step draft, you can go for parting line. These are more complicated draft, which we will see in our 3D modeling tutorial when we are going to model the exact thing, and we will utilize all these different options of the draft. Alright, so SolidWorks provides us with a very powerful tool called linear pattern, and what it does, it basically creates a pattern feature. So we can maybe select this Boss Extrude 2 and pattern it on the surface of Boss Extrude 1. So let's quickly start with the linear pattern, and the very first thing that we can do is come to features and faces, and we'll select features to pattern. So I'll come to my tree and select my Boss Extrude 2, and faces to pattern, we'll keep that for now like that. For the direction one, I can either select one of the edges, so let's say this one, and then instantly it gives me a preview of my pattern. Now this is, the spacing is too low, so I'll just increase it to 15. I can maybe go for 18, and yeah, that's fine. Now below that we have the option to give the instances. So this is for the number of instances. I will increase it maybe up to the edge. Yeah, that's fine. And we can also utilize this edge to give it a second direction. So let's go for it, and we'll increase the number of spacing first, and you can see it's colliding, so I'll increase the distance to 15, maybe the same distance which was 18, and that looks fine. So after that we can increase the instances to fill up the part like that. Okay, maybe we can keep this as 17, and once you're happy with your pattern, you can press the green tick mark over here, and you'll get a nice pattern of your object. Now if I come to my pattern and edit it, I can come down and you can see there is an option for instances to skip, and if I select it, I can pretty much like if you come to instances to skip, you'll get this option where you can get pink dots or points, which if you click, why does it look so tight? But it's okay. Okay, so if you click on these points, it will basically skip that pattern. So I can go for random points, and once you are happy, you can press the green tick, and yeah, those objects are now no more part of our pattern. So yeah, that's it for the linear pattern in SolidWorks. Alright, so just like we did with the linear pattern, the circular pattern is also work in the same manner, but let's see how we can utilize the circular pattern. So let's go for a circular pattern. Now the very first thing that we always do when we use pattern is we define the feature and faces. So I want this hole to be my feature for the pattern, and for the direction we need an axis. So basically what we can do is we can go for we can cancel the pattern, and we can go to reference geometry and create an axis, and to do that I'll select this face, and it knows how the axis should be, and that's what I wanted. Now we have the axis, we can go for circular pattern, and in the direction I will select my axis, and in the feature I will select my hole, and as you can see, as soon as I do that, it already knows how the pattern should be. Right, now let's say you have one axis. Even if you have uh, a different axis, you can utilize that as the direction. Right, now just like we did with the linear pattern, we can change the number of instances. So let's say we can decrease that or increase it. We can also define this for, let's say, about only 180-degree, and see how it's changing. Let's keep it to 360. That's how the circular pattern should be. And from here, as we did with the linear pattern, instances to skip, I can also do that. So I can click any of the pink points and I can skip those in my pattern, right? So that's how the circular pattern work in SolidWorks. So mirror command is one of the important tool inside SolidWorks if you are working with symmetrical kind of objects. So let's say we want to uh, use this body, and then we can mirror it uh, using the mirror command. So if we go for a mirror command, you can see we can pretty much do different things, such as we can go for mirror face plane, feature to mirror, or faces to mirror, and we have bodies to mirror. So let's say we select mirror face plane and we select this as the face. Now in order to do the entire thing, I will select my boss extrude in the bodies to mirror, and here you go, you have the preview of your mirror, and you get uh, same body which is attached to that face. So very easy, you can mirror your part, or you can say you can mirror your body. And let's say if I make any changes inside my uh, first sketch, so let's say I go for my sketch, and what I do is I can add pretty much a circle like this, and then I can trim this one. Alright, trim this one as well, trim this one as well, and then when I exit the sketch, the whole thing will be mirrored as well, right? So we can also mirror this, let's say from this face. So let's go for a mirror command once again. I will select my mirror face, so I will select this as my mirror face, and in the bodies to mirror I will select my body and press the green tick, and we can very easily mirror my body just like that. So mirror command is very useful, and in case if you make any changes to your original body, the whole thing will be copied to your mirror object as well. That you have to keep in mind while doing the mirror. If we talk about 3D modeling, Helix and Spiral are one of the important feature inside the SolidWorks panel, and in any under any circumstances you have to know how you can create a helix and a spiral for your 3D modeling. So in SolidWorks feature panel we have curves, and inside curves we have an option to create helix and a spiral. So let's select that, and the very first thing that you will get is you need to select a plane. So let's say I go for top plane. Now it will take you to the sketch environment, and let's say I draw a circle from the center like that. From here I can exit, and as soon as I do that, it's taking my previous values. So let's say this one is you can enter your you can define it by pitch and revolution, height and revolution, and different options. Let's use it by pitch and revolution because most of the time we are dealing with pitch and the revolution. So pitch is basically the distance between one turn and the second turn, right? That distance. And revolution is the number of turns. So I can see we have 9.5 revolution. I can make it 10, and you have an interval of 0.25 per revolution inside the helix. Now we can give it a start angle. So its start angle is basically this point from where the helix is starting. If I make it, let's say 90-degree, you can see how it's changing from that point to that point, right? We use it very often to suit our design condition. But let's say we keep it on 0 degree. Now also you can change it from clockwise to anti-clockwise, or whatever you can say, counterclockwise or anti-clockwise, it's the same thing. And we can do it clockwise if you want to. I can also give it some taper. So let's say we go for a 5-degree taper, and you can see if we go for minus 15-degree, that is also possible. Let's go for 15-degree, and you can see that's how the helix is creating. It's like a slanted helix, and once you are happy with that, you can press the green tick and you get your helix like that. Now to convert a helix into a spring, all we have to do is give it a profile. So for that we can select our right plane and go for sketching, and I will select this point for my sketching, and I'll create a circle, and just like that I can exit the sketch, and from there I can utilize the swept bar space, and we have already selected the circle as the profile. All we have to do is select the curve, and yeah, that's how you can spiral in SolidWorks, right? Wrap command is a very efficient tool inside SolidWorks, and inside the feature panel itself you see a wrap tool. Now wrap tool is basically used to wrap text or any other shape around a surface, and to see how it works we need a surface. So let's create a surface on a top plane. I'll go for a sketch. I will go for a circle, exit the sketch, make it a cylinder, press the green tick, and once we have our surface ready we can start with the wrap command, right? So let's start the wrap tool. Now it says we need any text or shape, so for that we are going to create some text. You can create shape also, but let's create shape text this time. So I'll select right plane and create a reference plane. I think that's fine, and we'll select the new plane and go for a sketch, normal to, and this time I will start a text. So we'll type in wrap command test, and over here we have already seen the text tool how it works. So we can use the font from here. Maybe we go for Verdana. That's fine. We can go for height in points and make it, let's say, 16. Okay. In case if it goes out, you can click there, and once you're happy you can do that. And also what you can do is you can drag it from this point and place it anywhere else, just like that. Right, let's say I'm happy with that. I'll press the green tick. I'll exit the sketch. Right, now we have our text on our plane. All we have to do is wrap it up on our surface. So let's start the wrap command. Now you can already select your text and go for wrap command. That way it will be easy. And let's say we have three options. We have the option to emboss, deboss, and scribe. So emboss basically means um, text will be thrown out from the surface, or you can say the face. So text will be coming out from the face, and with the deboss it's opposite, so text will be going inside the surface. And the scribe is simply a kind of print. It will be directly printed on the surface. No material will be removed, neither material will be added, right? Now let's go for the very first method, which is emboss, and in the wrap method we'll go for analytical, and we have to select the face. So I'll select this one, and as soon as I do that I'll get a quick preview, and from here I can change the thickness. So let's say I can increase or decrease it. So let's say I go for 1.2, press the green tick, and if I zoom in you can see the text is coming out because it's an emboss obviously. And you can change with the thickness of it. If you don't like it to be so much thick, you can change it to 1 mm, and that's fine. You can also change it to deboss now, and if I do that you can see the material is removed and the text will be printed on the wrapped on the surface. Right, so that's how you can utilize the wrap command in this one, which is basically scribble. It's nothing, neither it is adding material nor it is removing, so it's just like printing the text on the surface. Right, that's it with the wrap command. Alright, so here comes the interesting part of this class. With with the finishing of every class, we'll do some modeling. That's what we are going with all the classes. So you know the drill, right? We have done this in class 1 and class 2, and right now we are ending the class 3. So let's quickly model something. Now as you can see, I've already modeled this kind of vase, and I have utilized all the not all the, but some of the feature tools that we have learned already in our class. So let's quickly design this vase using those learning, and we'll see how we can proceed with the design. So I'll close this for now and we'll start with the new part. Press OK. You can name the part if you want to. Now every modeling starts with a sketch, so for this one I'll go for right plane and a sketch. Now I'll start with a line, and from here I'll start and draw my profile for the vase, and that's it. I will now utilize the spline command and maybe join 1, 2, 3 and 4, and press escape to get out of the spline command. Now we have the sketch of our vase. All we have to do is go for a smart dimension and provide dimension for our sketch. So let's say this is 17 and this is 28, and this overall distance could be 116. In case if it goes, you can always zoom to fit. And further I will utilize my spline points for the dimension. So from here to here, let's say this is 21, and also that point from this axis should be 85, and the next point from here, this could be 39, and this point from here. Okay, so let's go for this point and this axis. This could be 55, and the very last point we'll do is this one from here, which could be, let's say, 40, and also this point from here should be, let's say, 20. Now since our sketch turned black, which means it's fully constrained now, and we can proceed with the feature operation. So I'll exit the sketch and go for Revolved Bar Space. You know the drill, we have to select the axis of revolution, so I'll select this one and press the green tick to confirm. Alright. We have the body of our vase. Now the next thing that we have to do is we'll go for another sketch. So I'll select right plane, go for a sketch, press space and go for normal view, and here what we can do is we can simply go for offset entities and project this one. Right, and that's what we wanted. From here I can exit the sketch, and now what I will do is I'll go for another sketch. So I'll select the bottom face and go for sketch, press space and go for normal 2, and here I will take a circle, and somewhere between both these intersection you can zoom in if you want to. I will draw a circle and then give it a dia of 9.23 and then exit the sketch. You can zoom to fit. Now here I will utilize the Swift Bar Space and we have the profile already, and the curve is this one. So I'll start with the Extruded Bar Space. Since the profile is already selected, I just have to select the path. So I'll select this one as the path, and yeah, that's it. We'll press the green tick to confirm. Okay, now we have our feature, one of the feature for the base. All I will do is we can create multiple pattern. We can create a circular pattern of this thing around the body of the base. Now before doing that, uh, I want to utilize another important feature. So I will move this face with an offset. So for that you can type in move, and you'll get an option called move face, or either you can go to your insert feature, and from here you can also utilize the move face, but better you go from the command panel and type in move and select the move face, and the face will be this one. But see, you see that the adjacent face of the base is also selected, so we don't want that. So I'll do is I will go for sweep and edit feature, and we have to go into the option, and we have to uncheck merge result and then press the green tick. And now when we go for move face, I can separately select my sweep face, and then we can offset it to, let's say, 10 mm, and yeah, that's what we wanted, right? We don't wanted this face to be offset, and that's why we utilize the disable the merge result option in the sweep boss. Right, now here we'll go for circular pattern, and the very first thing that we will do is we'll expand our tree, and in fact uh, click our sketch one and show it so that we can select it in direction 1, and then we will come to feature and faces, and this time we want to select body. So I'll tick on body and not the feature and faces, and in the bodies I will select the move face. So I can select it from here or from the solid bodies. So I will select move face 1, and for the number of instances I can go for, let's say, 20, and obviously it should be equally spacing with 360-degree. From here I can press the green tick to confirm, and here we have our circular pattern ready, right? Now the next part over here is if we see in our tree there are 21 solid bodies, which is obviously all these different circular pattern with individual numbering. Now we'll utilize here a very important command called combine, and to do that I can go to insert feature, and from here you can select combine, and in the bodies to combine I will select all the solid bodies. Once you have selected all your bodies to combine, you can go for operation type as add, and then press the green tick, and now everything will be combined in a single body. It might take few seconds and you have the combine. Okay, now once you have done the combine operation, The other thing that we have to see is this face should be up to this one. So I'll utilize again the move face command. So let's go for move face and select this face, and we'll go for offset for a distance of about 15 mm. That's perfect. So I'll press the green tick. Okay, and after that we can do it one more time. So for that I'll go for move face again, select this face, and this time we'll go for only 2 mm and press the green tick. Alright, now you can see the everything is combined and we have a planar face on our vase. So after that what we can do is we can go for shell command, select this face, go for 1 mm and press the green tick. It will take few seconds to shell it, and once the shell is done we can go for the very last operation, which is fillet, and we can zoom in and select this as the face and go for 0.5 mm and press the green tick to confirm. Alright, so that's it. I think we have almost done it. Now it's very boring. Now you can see the this is pretty much simple and we haven't really done anything. So Solidworks has a very cool command which is called flex. So if you go into insert and feature, and inside feature you get this flex command. Now using flex you can basically if you see these pattern thing is coming right straight. So let's say you want to give it some twisting or bending or tapering, something like that. So there you can utilize this flex command. As you can see, the flex symbol is pretty much explanatory. Now this time I want to go for twisting, and for the bodies to flex I will select my fillet. Okay, and for the angle you can either go positive or negative. So let's say we go for -409 degrees, and we'll keep the rest of the options as same and then press the green tick. It will take few seconds to complete the flex operation. Right, so here we have our finished model, and as you can see we have given a nice sweep kind of uh, we have given a nice twist to our sweep, and this vase looks more attractive now rather than the regular sweep which was going vertical. Right, and yeah, that's it for this class, and I hope you guys like it, and if in case you have any doubts with this class, feel free to comment down below and subscribe to the channel if you're watching this. Thank you guys, peace out.